Have you ever wondered why there are so many different types of battery chargers on the market today? In this video, we'll explore the technology behind smart chargers and understand why different battery chemistries require unique charging approaches. Because of the complex technology built into modern vehicles, the demand placed on a car's battery is now greater than ever before. This means more sophisticated, smart battery chargers are required in today's workshops. Compared to an old-style linear charger, a smart charger is able to perform many other functions, which are designed to improve battery life and its ability to maximise 100% capacity. We must remember that there is a wide variety of battery chemistries available today. These include lead acid, deep cycle, AGM, calcium-calcium, gel and lithium-ion. The need for a battery charger that tests, conditions and maintains a battery in a state of optimum condition, which provides the longest service life and the highest capacity, is imperative. A battery derives its charge from three active materials: sulfuric acid, lead and lead oxide. Charge is intended to regenerate the active materials from the lead sulfate formed during the discharging process, known as sulfating. In the process of a battery discharge, sulfate ions from the electrolyte react with the lead electrodes to form lead sulfate. Upon recharging, these compounds dissolve with the sulfate ions returning to the electrolyte. During normal use of a lead-flooded battery, small sulfate crystals form, but these are normal and are not harmful. However, during prolonged charge deprivation and low electrolyte levels, the lead sulfate converts to a stable crystalline and deposits on the negative plates. This leads to the development of large crystals, which reduce the battery's active material and thus its charge and performance ability. Using an old-style recharger, battery recovery at this stage of deterioration would be unlikely. However, with the new technology of smart chargers, a series of stages during the charging cycle makes it possible to desulfate the plates and rejuvenate the battery. Your choice of charger will determine the quality of the charge, so it's crucial you make the right decision. Older style constant current charging maintains a pre-selected current until a specific voltage has been obtained at the battery. Without careful monitoring and control of this charger, overcharging and overheating a battery can occur, causing long-term damage or immediate battery failure. This technology is now outdated, so it's not recommended for use on today's batteries. On the other hand, quality smart chargers, such as the range from CTEK, are fully automatic and suitable for modern batteries. They have the ability to communicate with the battery during the charging process and only supply charge depending on the battery's exact needs, including monitoring the battery temperature. Models like this are generally spark, dust, shock and weatherproof. They most commonly operate in a series of stages, including desulfate, charge, recondition, analyse and supply and maintain all types of batteries. Ultimately, this can prolong the battery's service life and capacity. Each type of battery chemistry needs to be maintained in a slightly different way, but all battery types can be charged, maintained or rejuvenated with a smart battery charger using its variable mode selection. Let's now take a look at each step of the charging phases in a typical smart charger. A charging curve or algorithm describes how the battery obtains its energy during the entire charging process. During the initial desulfation stage, a high-frequency voltage pulse assists in the regeneration of a deeply discharged battery. This method of pulse charging can also help reduce the excessive sulfate crystals that may have formed on the battery plates during its discharge state. The soft start phase tests if the battery can accept charge. This step prevents charging proceeding when the battery has an internal fault. The bulk stage is the main charging stage, where the charger will operate at its maximum output current and voltage until it reaches 80% of its capacity. After the bulk stage, the charger will automatically begin to reduce its current output as the battery approaches maximum capacity, while still maintaining the required voltage. When the current reaches a predetermined level, the next stage will be initiated. During the analyse phase, the charger tests if the battery can hold a sustainable charge. Batteries that cannot hold a predetermined charge may need to be replaced. Most chargers allow you to select an additional program known as Recon. During the Recon step, voltage increases to create controlled gassing in the battery. Gassing mixes the battery acid and gives back energy to the battery. The float phase maintains the battery voltage at a maximum level by providing a constant voltage charge. In the pulse phase, the battery will have reached maximum capacity. The charger monitors the battery voltage and gives a pulse occasionally to keep the battery fully charged. In the pulse maintenance mode, the battery will be allowed to naturally self-discharge to a certain level before being fully charged again. Not only does this avoid the risk of overcharging, but as the battery is being cycled as it would in a vehicle, the lifespan of the battery is extended considerably. The quality of the charging voltage and current is very important. A high current ripple can heat up the battery, which has the aging effect on the positive plates and can cause premature battery failure. High voltage ripple can also harm other electronic equipment that is connected to the battery. Most smart battery chargers produce very clean voltage and current with low ripple, which will maintain a battery's health with minimum stress on the battery during charging. Before charging a battery, always note that lead-acid batteries can emit hydrogen gas from their cells, which is highly explosive and corrosive. Correct connection methods, ventilation and PPE should always be observed. Today, we are using the CTEK MXS10EC as an example. Connect the charger to the battery. Positive lead to the positive on the battery terminal and negative lead to the negative on the battery terminal. Plug the charger into the wall socket. When switched on, the green power lamp will indicate that the mains cable is connected. The error lamp will indicate if the battery clamps are incorrectly connected. The reverse polarity protection will ensure the battery and charger will not be damaged. Pressing the mode button will select the required charging program, indicated by illuminating each chosen mode. Then you can monitor the 8-step display through the charging process. The battery is ready to start the engine when step 4 is lit. The battery is fully charged when step 7 is lit. You can stop charging at any time by turning off the power supply. Then disconnect your negative lead from the charger to the battery and then the positive lead. Selecting the correct program is vital to ensure the charging process is successful. The vehicle symbol selected is the normal battery program. Use this function for wet batteries, calcium, maintenance-free and gel batteries. This mode charges at 14.4 volts at 10 amps. The AGM button activates the AGM battery program. This mode charges AGM batteries at 14.7 volts at 10 amps. Use the recon feature once a year and after deep discharge to maximise lifetime and capacity. The recon program is step 6 in the normal battery program and charges at 15.8 volts at 1.5 amps. The supply feature produces a 12 volt power supply whilst your battery is removed from the vehicle. It can also be used for float maintenance to keep your battery to 100% capacity. The supply program activates step 7 without any time or voltage limitation, charging at 13.6 volts at 10 amps. There are many smart chargers available on the market today, and most manufacturers will offer different models based on different battery types and charging requirements. Let's take a look at some different models offered by one manufacturer. Designed for professional use, the CTEK MXS 10EC has a wide range of features, including an automatic diagnostic function that tests whether a battery can accept and hold charge and a 12 volt supply mode. It's capable of delivering 10 amps in an 8-step charge process and recondition mode. The Pro 15S, on the other hand, is a powerful and fully automatic 15 amp battery charger and maintainer, compatible with any 12 volt battery. The key difference is that it features a dedicated lithium mode, which makes it suitable for use with today's modern batteries. For the professional workshop, the Pro 25S is a highly efficient 25 amp battery charger and power supply, generally used for computer flashing or retrieving fault codes with scan tools. Finally, the Pro 60 is a 60 amp battery charger and power supply. This advanced battery management tool provides fast, efficient and safe battery charging that supports batteries during diagnostic servicing, including pass-through software upgrades. It also supports lithium-ion, wet-flooded, calcium-calcium, AGM and EFB stop-start batteries. So when it comes to battery charging, make sure you're a step ahead and you understand how this technology works before beginning your work.